Hello, good day. Welcome to today's tutorial on Aspen Hysys. I'm still your tutor. Olóyèdè Emmanuel Olúṣèyí from the Department of Chemical Engineering of the great institution Ladoke Akintola University of Technology. And today we'll be doing some simulations together. Today we'll be working with distillation column. I'll be teaching you how to model a distillation column, how to work your way around it, how to get your distillation column converged. That's what I will be teaching you today. And today we'll be using a question to solve a distillation column. And right on your screen you can find the question. It says we need to separate a mixture of 5 paraffins into light and heavy fraction by using a distillation column with 12 trays, a reflux condenser, and a kettle boiler. The free stream 100 pound-mole per hour consists of 3% mole percent of ethane, 20% mole of propane, 37% of normal butane, and 35% of normal pentane, and 5% of normal hexane at 225 degrees Fahrenheit and 250 psi. That's our inlet pressure, which enters the column at the 6th tray. Yes, that's just the question. Let me just leave it for you to read. You can as well pause the video to read the question very well. So I'm going to get into my Hysys interface. I've opened my Hysys interface, and I told you in our previous tutorial that the first thing to do is to select your components. So let me just look at what our components are. We have ethane, we have propane, we have normal butane, we have normal pentane, and normal hexane. So from ethane to hexane, that's what we are working on. So we have ethane, and then just press Ctrl, propane, normal butane, normal pentane, and normal hexane. So I can just add the 5. Those are the 5 components we are working on. So as you can see, my component list has changed to blue. So it means I'm done with components. So I can just go to my fluid package. And what's our fluid package? Our fluid package is SRK. So I'm going to be using SRK. You can just click on add. So I'll just look for SRK here. SRK, yes, is okay. So I can proceed to my simulation. Yes, now I'm in my simulation. Environment. So I can start. I don't want my palette to be here. I'll just put it somewhere here, so it will fit with the screen. So I can just go ahead and add my feed stream. There are two. I forgot to tell you that there are 2 ways at which you can add your stream. You can add it by clicking here and bringing it here, or you can just add it by double clicking on your material stream here. So if I should double click, it will open the interface straight. So let me just call this my feed. So the temperature is what? Let me get the temperature. The temperature is 225 degrees Fahrenheit. So I'm going to be entering that 225 degrees Fahrenheit, and the pressure is 250 psi. So let's get back to our simulation. I have 225, right? I hope I'm right. 225 degrees Fahrenheit and 250. So 225 degrees Fahrenheit. 225 degrees Fahrenheit. So it's still in centigrade, so I have to change it to Fahrenheit. And you can see that it changes this to 107.2. That's the equivalent. So you can see that after inputting 225 degrees Fahrenheit, it changes this to 107.2. It's just the equivalent of 225 degrees Fahrenheit in degrees Celsius. So you are still safe. So I can just put here, I have my 250 is in kilopascal, so I have to change it to psi here. So as you can see that it converts it to kilopascal straight. So my molar flow rate is, I think it's 1000 pound mole, not in kilomole, so I can just change this to pound mole per hour. Pound mole per hour. Yes, and it consists of 0.3 of ethane, 0.03 of ethane, 20% of propane. So let me just take this back. Let me take this. Sorry about that. So I have to input my composition, and if I want to do that, I can do that in two ways. I can double click on this. It will bring the interface for me, so I can as well go here. But personally, I love it this way. So I have 0.03 of ethane and 0.2 of propane. 0.2 of propane. I have 0.37, 0.35, 0.37, 0.35, 0.37, 0.35, and the last one will be 0.05. So I can just input it. So I have inputted all my composition, my mole fraction. I can just press OK. So Hysys has calculated the stream. So I need to add my distillation column. So I just click on column. After clicking on column, I just choose distillation column sub flow sheets. I'll bring it here. So after bringing it here, I just have to connect all my streams. I can double click on it. My inlet, my number of stages is let's check the question. What the number of stages? 12. Number of stages is 12. So I'll just change this to 12, and I will change my inlet stream to feed. As you can see, it's telling you something here that 6 main tour. It means your feed is entering at the 6th stage. That's what it's telling you. So if you don't want your feed to enter at the 6th stage, you can change it. I just change it anyhow here. So but I will still want it to enter at the 6th stage. So I just have to leave it there. I'm not going to be working on partial reflux. I'll be working on full reflux. I'm working on full reflux. Let me just connect my stream. This is Q. That is the energy of the condenser, and this is the energy of the boiler. So let me make this my top. Let me make this my bottom. I think I'm good to go. So you will notice that now I can click on next. That is because I've added everything that I needed. So it mean everything I need to fill in this form is not yet filled. This next will not be highlighted, so I can just click on next. So now we have so many types of reboiler. So I'm just going to be using my regular Hysys reboiler. So I can click next. Yes, condenser pressure and reboiler pressure. Let me see if we have any information on that. Which ends out on the 6th tray, counting from the top. The condenser and reboiler pressures are these and these. So we have condenser pressure to be 248 psi and 252. So 248 and 252. 248 psi and 252. psia. So I'm done with that, so I can click next. As you can see, the temperature of the condenser or the boiler is optional. You can decide to input it and you may not input. If you have information for it, you can put it. Let me see if I have information on it. I don't have any information on it, so I'm good to go. So I can just click next. This place too, I'll be explaining some things to you. For you to get your distillation column converged, you need 2 degrees of freedom. You need to specify 2 degrees of freedom before Hysys can calculate your distillation column for you. So here, Hysys is telling me to enter this, the reflux ratio and the vapor rate. If I should enter those 2, Hysys can calculate my distillation column. It can calculate my distillation column can be converged. But in a case whereby I don't want to work with vapor flow, vapor rate and reflux ratio, there is still a way for us to do it. But first, let's just input it. I think our question has given us that the preliminary design specification require a reflux ratio of 6.06 and vapor overall product of 226 per mole. So I can just input that vapor reflux ratio of 6.06 and molar flow rate of 226 per mole per hour. So let me see if we are right. 226, yeah, 226 per mole per hour. So I can just click on done. I'm done. I don't have any side operation, so I can as well just go to done straight. Unlike other unit of operation whereby as you are inputting your stuffs, Hysys is calculating it. Distillation column is not like that, so you have to tell Hysys to calculate before it calculates. So I can just click on run, and in few iterations my Hysys would have converged. It means I have my result already. So with that specification, I can check my results. My result is available. I can go to worksheet. This is my results. So here, the top product, we have molar flow rate of 102.5, and bottom we have molar flow rate of 351.21. Let's see the composition. For the top product, we do not have any hexane in our top product, and we have very little pentane, but we have more of propane and we have more of ethane. Butane is distributed here. So checking our bottom product, we do not have ethane at all. We do not have ethane in our bottom product, and we have much of butane, much of pentane, and hexane. We have all of hexane at the bottom. It means no hexane at the top. All of the hexane is in the bottom, and no ethane at the bottom, but all of the ethane is at the top product. So that's just it. If we're able to get our result, we'll be able to get our result. But I told you something the other time that if we are not, for you to get your Hysys converge, you need to specify the 2 degrees of freedom. The 2 degrees of freedom that we specified was the reflux ratio and the overhead vapor products that we specified the other time. Let's check. We specified our top product to be equals to what? To be equals to 226. If you should check that drop down stuffs, is writing it, though it is in 102.5 kilogram mole per hour, but we still have something 226 per mole per hour, which we inputted the other time. So those are the 2 degrees of freedom. But now We don't want to work with that. So, when we check our question, let's check our question. When we check our question, it's telling us that subsequently the design is modified to ensure propane overhead flow of 191 palm mole per hour and N-butane bottom flow of 365 palm mole per hour. So we are going to be making that adjustment. So let's go back to our simulation. I can just go to my monitor, and I can just say add specification. So when you click on add specification helps you to, it gives you the freedom to specify what you want to give to Hysys. It gives you that freedom. So now I want to tell my Hysys that I need propane, the amount of propane at the overhead product to be equals to 191 palm mole per hour. That is propane flow at the top product. So let's add that. So I just go to my column component flow. Yes, column component flow. Now you just say add specification. So you can just say propane at top, the name propane at top. Let me just denote it that way. So I can, where do I want it? It should be at my top. Yes, the base should be molar, and our value is what? Let's check our value. Our value is 191 palm mole. 191 palm mole. So palm mole per hour, and our component is propane. So I'll be able to add that, so I can close this. So I will still click on add specification again to add for the bottom product, add column flow. Yes, add specification. So what's the, yes, we are asked to N-butane 365, N-butane 365 at the bottom. Yeah, butane at the bottom. You can denote that with anything you like. It does not 365, we have 365 palm mole per hour. So we've successfully added that too. So as you can see, Hysys is still operating based on the first stores we give to Hysys, that is the reflux ratio and the overhead vapor product rate. But now I don't want to work with these two specifications again, so I have to make it unactive. I have to, as you can see, as I unclick that, my distillation column is unconverged, and if you look at the degrees of freedom, is writing 1. It means I need one more. Let's see if I click this again. Now my distillation column is converged and my degree of freedom is saying 0. It means I don't need to input any other thing again. So I told you the other time that, and working with this, you see our weight error. Our weight error is just minus 0.00000, and this ought to be 0.00000. So I'm not needing this, so I have to uncheck it. So, and these are the two stuff that I want to specify for Hysys. I need one more. So let's see what happens. So Hysys is able to converge, is able to calculate it at how many iterations? I think at the third iterations. So it means I have my results, so I can go to my worksheet and I can see. So we have it, we have this, we have all these compositions, everything. So our result is ready. So we can just you can go to column to check your, let's go to performance, here. So, and let's go to column profile. So as you can see that Hysys has calculated everything for you. Hysys has told you, Hysys has been able to tell you that for you to have that result, it means your temperature of your condenser should be 46.06 and the temperature of your boiler to be 128.8. And he has been able to tell you what temperature you must set your plate, each plate to. And also the same thing with prayer. So you can see the prayer profile. So that's just it. So you can come in. Yes, you can see that operating the distillation column at that specified degrees of freedom, it means our reflux ratio must be 8.545 and our boil up ratio must be 2.121. So let me go to, you can just say feed versus products to check some stuff there, and let's see, you can make a plot temperature. So you can just say view table. Okay, so I can view graph as well. See, this is my temperature profile, like this. So, and you can as well check any result you want. This is condenser versus the boiler. Condenser temperature is this and the boiler temperature is this. The duty of the boiler is this and the duty of the condenser is this. So you'll be able to, Hysys has been able to calculate what you need for you. So it depends on what you want Hysys to do for you. So you specify everything. All Hysys does is to calculate it for you, but everything you will be inputting into the Hysys must be something that is reasonable, or else your distillation column will not be converged. So you have to take note of that. That's why you, as a chemical engineer, at times you have to research about some things before you just come and do your simulation. Or simulation can also serve as let me see, a research for you, whereby you can just play through values, play through data, and see the best possible results for you, so that you can use to make a very logical conclusion when you're on the feed. Yes, so I think we are through with today's tutorial. So you can just try to save it. You can save by pressing Ctrl S. So you can just type in the name, but for now I don't think I want to save it, so I will just have to close this. Thank you so much for being part of today's simulation, today's tutorial. It has always been nice having you around. You can always check through previous video tutorials, and you can always call us for any assistance should you have any problem. Once again, my name is Oloyede Emmanuel Oluwaseyi. I'm from the Department of Chemical Engineering, Ladoke Akintola University of Technology, Ogbomoso, and I wish you all the best in your career. Thank you so much for listening.